Hi everyone, welcome back. So we have understood everything about the supervised learning. We already written a code for it. Let's also look at the flowchart to understand it. So here we have different types of animals present, which are all labeled. So labels are like elephant, the structure of elephant, cow, and the camel. So we have all the data, the images of the animals grouped all together with labeled as elephant, camel, and cow. Now we are going to provide these images along with the labels to our algorithm where the algorithm is going to process the data. So here we are providing the training data set along with the desired output. So we have images along with the labeling. So everything has been trained to algorithm. Algorithm is going to train itself, then it's going to process the data if you provide another sample. After processing, it is going to predict. If you provide another image of elephant, it is algorithm is going to predict it's an elephant. If you provide another image of cow, it is going to predict as cow. And then if you provide an image of camel, it is going to predict itself as camel. So that's how supervised learning work, where you provide the data with their labeling. Let's move on to the next type of machine learning, which is basically unsupervised learning. So unsupervised learning is where you model learns from unlabeled data. So here we only provide the input, but we doesn't provide any output to it, which is no labels have been provided here. So here the task of the machine or the model is basically going to find the hidden patterns, the groupings in data, and then it is going to make a prediction. So for example, let's say we just want to create a model which is going like how your model is going to first thing, how your model is going to learn itself. So it is going to group similar things. It will group for example, if I'm training my data based on so many different categories, which includes, let's say, sports, politics, tech, infrastructure, like so many different categories. Model is going to group all the news articles. Okay, let me just explain you the scenario in a very simple words. Let's say I just want my model to predict which news belongs to which category. Like, is the news sports? Is it politics? Is it tech? Okay. So starting with the data, we trained or we provided around thousands of samples of news articles where there is no labeling present. Okay, they are all grouped in a different, like they are all submerged together. So we have news, like let's say we have 50 news articles for the sports category, 50 of politics, and 50 of tech. So these all 150 samples we have made our computer to understand, make some patterns, understand the patterns, like what are the words which are used in sports, what are the words that are used in politics, what are the words that are used in tech. So every pattern and everything is going to be understood by the model itself. There will be no labels provided here. After that, when I give a another news article to my computer, to my machine model, it is going to predict me, does it belongs to sport, does it belong to politics, or does it belong to tech? So that is how unsupervised learning works, where you train your model with unlabeled data, only the input data and no output data. So how model is going to learn? Model is going to learn by grouping things all together. So model is going to group all the articles which are sports article. Model is going to group all the articles that are politics and all the articles that are tech. Then it is going to understand what's the thing common in sports, what's the thing common in politics, what's the thing common in tech. So that's how the learning of model happens. So if we look at a real world scenario, so there is application or a software which is customer segmentation. So based on the behavior of the buyers, based on the behavior, we group those buyers all together. So customer segmentation is one of the model. Then we have market basket analysis, which is like this market basket analysis is one of the model which has been used in so many supermarkets, whether it be Reliance, whether it be DMart, whether it be Vishal Megamat, or for the person who don't know about that, let's imagine like too many for a big bazaar. So whatever the supermarket is, this one of the model has been used to all those places. So what happens here is, which I like we submerge things. Okay, for example, let's say there's a fruit which has been always okay. Let me just give you something. Okay, okay. So for example, let's say the bread has always been brought with either the uh, jam or either with any of the substance or any of the product which has been used with breads. So we know what are the items that are brought together, right? So what will happen here, we want customers to focus on other things as well. So what will happen is, let's say we just discovered a new jam which is different other than the fruit jam that is available, and we want customers to buy that. But as usual, what customer does is they buys the bread and then they buys the jam. We know they are going to do this. So what we do is we just keep the new jam in just to near to the bread. Okay. So because we know they will always look at those items of jam. Or what will happen is we will always keep together those items that are always brought together. So that's how the model works here, or where just we just make an analysis like which items have been brought together. We keep them together so the customer don't have to look in the whole market. They know that this is how they are going to buy. So this is how things market basis analysis works, and the algorithms for the unsupervised learning are K-means clustering algorithm, hierarchical clustering, principal component analysis, which is PCA, and autoencoders. So K-means clustering is one of the basic and the most used algorithm that we used for the unsupervised learning. And if we understand unsupervised learning respective to NLP, which is natural language processing, so there what will happen is we are going to group all these similar words together. So if I took an example of those positive and negative reviews, let's say we will be grouping all the positive reviews together, we'll be grouping all the negative reviews together, and then how we'll make a prediction. So let's jump back to the code and let's create a model which is for the unsupervised learning. So what I want is, here I want my model to predict that the specific text to belong to which category. So what I'm going to write is, I'm going to write multiple text. Okay, let's say I write I like football, Messi is a great player. So we know these two texts belongs to the sports category. Similarly, I'm going to write Python is easy to learn. I enjoy coding in Python. So we also know this that this specific code, this specific category belongs to the tech category. Okay. So before starting with, let me tell you one thing. See, my model is not going to predict me the category, like if it's a tech category or if it's a sport category. It's just going to group things together. It will group all the tech categories together, and it will group all the non-tech category, which is let's say sports category together. For example, in this example, if you say we have inputted a lot of watermelons and apples to the model, so they are all in different category. We have apple, watermelon, again two apple, then watermelon, two apple, and watermelon. Now what my model will do as an output, it will group all the apples together and all the watermelons together. So based on their color, their structure, and their everything, model is going to predict that this also belongs to this specific category. It will predict that this another product belongs to this apple category, so it will belong to the first category. Similarly, it will predict that this another object watermelon belongs to this specific category, so they are all together. So that's how the unsupervised learning output predicts. Let's jump back to the VS Code and let's create a model, which is the topic clustering model. We are going to cluster things together. So first thing first, we need the sklearn dot feature extraction dot text. Now from that specific library, we need to import the count vectorizer, which is very important whenever we are working with text. Another thing is we'll be using the k-means clustering algorithm. So we need to import k-means clustering from sklearn.cluster. So it is present in the cluster library. The logistic regression, linear regression were present in the linear model. So from sklearn.cluster, we'll be importing k-means. Sorry, k-means. Perfect. Now I'm going to provide the text here. So let's provide a text in the form of a list. Okay, so I'm going to write I like football. That's the first text. Then I'm going to write Messi is a great player. Second text. Now let's write the third text, something which is related to tech, which is, let's say, Python is easy to learn. Perfect. Let me write I enjoy coding in Python. So now my model is going to understand which text belongs to each other. Like, is I like football or Python is easy to learn belongs to one specific category, or these two belong to one specific, or these two. That model is going to predict for me. Okay. First thing was we need to create a variable which is vectorizer. We will need to call the count vectorizer function to fit and transform everything. So create a variable x. X is equal to vectorizer dot fit underscore transform. We pass the text to this transform. Perfect. So it's just going to split your sentences into individual words and then understand it. Now we'll be calling the K-means clustering algorithm, providing the number of clusters that we have, some of the random state value, like how randomly you want them to predict them, and then fit the data. So I'm going to create a variable first, which is k-means is equal to, we'll call the function which is k-means as the module. First thing is we are going to provide the number of clusters that are present. Number of clusters means your data is belonging to which category. Like currently we have two category. One is the tech category and another is the sports category. If I include more topics which includes to politics category, then number of clusters would be 3. So we need to make a model understand how many categories are present. Then only model is going to understand the different ways. If we don't provide them, then how model is going to understand, like does it belongs to different categories or single category? With the based on number of clusters, it is going to understand that part. Then we provide random underscore state is equals to 42. That's a random value based on which we want a model to learn. See, I told you this random function we use a lot of time. So now we fit the data into the x variable, and now we'll be predicting something. So for every text that is present with the labels that are there in a file, which is my labels file. So first is I will be passing my text, then I will be passing my k-means algorithm dot labels underscore. Here I will be printing the clusters. So my text comma it belongs to which cluster comma label. See, let me just tell you what is happening here. So we imported two of the functionality. One is the model, second is the count vectorizer, which is going to transform my words. Now we provided a list of sentences which is going to understand, like a list of sentences to predict, to make a model learn. It's a input data. Then we vectorize our sentences into individual words, so that model is going to understand those individual words. We pass these individual words to the model, we fitted them, we pass the number of clusters which are present, the category that you have, and a random state value. Then we created a for loop where it will be printing the text, this text, and it belongs to which cluster. So based on the labels that is going to happen by the k-means dot label function, it is going to give it which the text belongs to which cluster. So let's run this model and let's look at the data, then we'll be understanding. See, I like football belongs to cluster 0. Messi is a great player belongs to cluster 0. Now Python is easy to learn belongs to cluster 0, and I enjoy coding in Python belongs to cluster 1. This is a wrong prediction. Definitely we know because of very less number of data, Python hasn't predicted a very good here. We can change this thing. We can have Python is easy to learn as coding. Now let me run this. Okay, now perfect. Now we got these two data to be present to cluster 1 and this two as a 1. So what happened in unsupervised learning is Python is going to predict the grouping. Python predicted these two sentences belongs to one category and these two sentences belongs to one category. We just trained the input data and it predicted itself. It just gives us an output that the first cluster 0 is basically the sports cluster and the coding sentences is basically the tech cluster. So it just predicted 0 0 that belongs to 1 and 1 1 it belongs to one group. So that's how unsupervised learning happens here. So we can also understand one of the another example of this what I would say, supervised learning or unsupervised learning, which is spam versus not spam. See, I want you guys to do it by yourself. I want you guys to create a spam versus not spam model by yourself and make a prediction. Like which of the spam versus not spam, like make a model by yourself. Train your model with email samples, provide a labels to it. Like for the spam, you can use one, for not spam, you can use zero. Vectorize your data, train your model, and predict it. It's very easy to do. And one more thing, I would suggest you to try another algorithm there. We already used logistic regression and K-means clustering. The spam versus not spam is definitely a supervised learning model. So look at all the supervised learning models, algorithms that are available and try to do it by yourself. If not, we'll be looking at in the next video. First, try to do it by yourself. If you're stuck, then you can look at those data.